Yo, Senior G here, coming at you guys with the graphing quadratic functions and vertex form video part 2. So if you've not seen part 1, please go watch that first, as I'm expecting you guys to know what's in it, okay, and I know everything from that video. So real quick review. This is the vertex form for a quadratic function. This exponent of this is squared exponent right here, this exponent of the power of 2 is what makes this a quadratic function. Okay, so because it has this power of 2 right here, that's what kind of helps us know or tells us that the graph is going to make this parabola, which is the U shape. Okay, so vertex form, HK form also is very similar when we did absolute value functions, where our H and our K make our vertex, okay? And our vertex is always negative HK. So it's always the opposite of what's inside these parentheses here. So if this is a positive, that means this is negative. If this is negative, that means this is positive, okay? And that's what always gives us our vertex. Okay, so whenever we're graphing quadratic functions, we always want to just find the vertex first. That's always the first step. And the vertex is always just the bottom or the top point of the graph. It's where the two sides intersect, okay? Then what we do is we just pop points on the left and the right side, and it's going to be symmetrical. Okay, so what happens is this H and this K shifts the parabola left and right. Okay, whoops. It shifts the parabola left and right, and it also shifts the parabola up and down. The K, because it's the Y value, moves it up and down, or the H moves it left and right. Okay, what we're going to talk about today is what this A does to the parabola. Okay, and this A, if there's a multiplier on the outside, what it does is it actually shrinks it. So it might make it smaller, or it might even make it fatter. Okay, and so we're going to look at what that looks like and how that affects it. So here I have the graph y equals 2x squared. So the first thing is we got to figure out what our vertex is. So the vertex, I don't see, there is no minus h anywhere inside parentheses, and there's no plus a number on the outside. So the vertex is 0, 0. Okay, the vertex is just 0, 0 because there is no shift here. Okay, so I know that point right here. I can already just plug that into this table. So now what I want to do is you always want to do the points to the left and to the right of your vertex. So my first point to the right is going to be 1. So I'm going to do 1 and negative 1. And they should give me the same answer because it's symmetrical on each side of the vertex. So if I figure out what x is, when x is 1, what's my y, I can do that. So with exponents, always do your exponent first. Okay, order of operations. So I'm still going to do 1 squared, and then I multiply by 2. Okay, so 1 times 1 is 1, and then I'm multiplying it by 2, so my point is 1, 2. Which means negative 1 I will also get 2 because it is symmetrical. If I were to plug in 2, again, do your exponents first. 2 squared is 4 times 2 is 8. So 1, 2, 3, 4, 5, 6, 7, 8. And it's going to be symmetrical on the left side. So if you guys notice, this is a little bit skinnier than the parent function of just x squared. If I were to grab x squared, I'll do it in purple real quick. So without that 2 in front, remember it just goes up 1 over 1. And then we go up 3 here, 4. So notice how it's just doubled in size. It's doubled on the y values, okay? So it is a lot skinnier. Not a lot skinnier, but it's definitely skinnier. Okay, let's look at another one. So now I have y equals 1/2 x squared. So again, first step, find the vertex. Hopefully we notice right away that there is no any extra numbers besides what's being multiplied by x squared. So my vertex is 0. Okay, 0, 0 is my vertex because there is no shifts going on. All right. Now, again, we want to figure out where we're at on the points to the left and to the right. So I'm just going to look at 1 and 2 right now. If I were to plug in 1, I'd have 1/2 times 1 squared. I have to do my exponents before I do my multiplication. So 1 squared is just 1. So I get 1/2 times 1, which is just 1/2. So now, instead of going all the way up to 1, I'm only up to 1/2. And it's symmetrical on both sides. Okay? So I'll plug that in my table just to show you guys. Now if I were to plug in 2, 1/2 times 2 squared. Well, 2 squared is 4, so I get to multiply 4 by 1/2, and that's going to give me 2, 1, 2. And it's symmetrical on the other side. So there's my parabola. Okay, and it's also probably good to even go up to 3 and just see what that would do. That would give you 4.5. So I might use a little bit off, which would be right there, so it should be going through that point. Okay, that's that. So now let's look at another one, but now let's look at the one that has a different vertex. Okay, so it's not going to be at 0, 0. So this one's got everything included. So it has a horizontal shift and it has a vertical shift. So the first thing we need to do is identify where our starting point, where our vertex is of this graph. So remember, the vertex is negative hk. So because the vertex is negative hk, it's going to be the opposite of what's inside the parentheses is going to be my x, and then my y value is just sitting right here. So because it's negative 3 on the inside, that means it's positive 3, and then the y value is 2. So 1, 2, 3, 1, 2. There's my vertex. I also want to look and determine if this graph is opening up or down. The way we know that is if this number in front is positive or negative. And again, when you fill out your table, you'll be able to see that. Okay. So because I'm starting at 3, 2, I want to pick points to the left and to the right. So picking 1 doesn't necessarily help me. It kind of does, but it's not giving me the points that are right next to my vertex. So really what I'm looking at is 2 and 4. Because that's when my x is 2, that's the point, that's going to be the value right next to my vertex. It's going to tell me kind of how fat or skinny this graph is going to be. Okay, and if you find the value for 2 or you find the value for 4, it's going to be the same for either one. So really, I can just do x is 4, x is 5. So if I go 4, 5, that's also going to give me 2 and 1 because again, it's symmetrical. So the points on this side are going to be the same as the points on this side. Let's even do 6 just because. Okay, so from here, you guys, you do have to just plug it in real quick and solve. There aren't too many shortcuts for this. So you'll notice patterns later on with certain multipliers, but like with ones like 3, you might just want to just plug it in. So I've got 3 times 4 minus 3 squared plus 2. So that's me plugging in 4 in for my x, and now I'm just going to solve. So I've really got 3 times 1 squared plus 2. Okay, so that's just going to be 3 plus 2, which is 5. Because 1 squared is 1, times 3 is 3, 3 plus 2 is 5. So 1, 2, 3, 4, 5. So if we notice it's going up at a quicker rate now because of this multiplier by 3. Instead of just going up 1, now it went up 3. Okay. Let's do it with 5 real quick. So with 5, if I were to plug in 5 right here, I have 3 times 5 minus 3 squared plus 2. So again, I just have 3 times 2 squared plus 2. Do your exponent first. Don't multiply by 3 first. Do the exponent first. So this is 3 times 4 plus 2. And that's going to give me 14, and 14 is probably going to be off this graph, but we'll try it anyways. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So it's all the way up here. So I know, just to show you guys, it's going to go all the way up there. Okay, there's my parabola. Okay, so again, see how it exponentially, it really quickly, dramatically increased, and we got skinnier just because of the fact that now our y values are increasing so at such a quicker rate with this multiplier right here. Okay, and that's it, guys. And so if you wanted to try this one real quick, try this one. Let's take a look at this one. Maybe pause the video, try to graph it on your own, and then you can come back and check to see if you did it right. So right away, our vertex we can find easily, -1, +4. So that means it's the opposite, which is 1, 4. So there's my starting point. Whoops. So my starting point's at 1, 1, 2, 3, 4. Okay, am I opening up or down? Some of you will notice right away it's opening down because it's negative, so I've got to be aware of that. I'm looking for points to the left and to the right, so I'm looking for points at 0, 1, 2, 3. So let's just look at, 2, 3, 4. So I'm going to look at 2, 3, and 4. I like to look on the right-hand side because generally speaking on the right-hand side, that's not going to give me negative numbers, and I just don't like to deal with negatives. So -1/4 times 2 minus 1 squared plus 4. So this is going to be 1 squared, which is going to give me negative 1/4. Because if I 1 squared times negative 1/4 is 1 times 1 negative 1/4, which is negative 1/4 plus 4. And that's going to give me 3 3/4. Okay, so this is where graphing is going to get a little bit tricky. So when x is 2, I'm at 1, 2, 3 3/4. I'm all the way up here. I'm pretty close to 4. And that means it's going to be the same thing at 0. So right now, it's like barely even opening up into that U shape. Okay. Let's look at what happens though when I plug in 3. So if I plug in 3, I'll have 3 minus 1 squared plus 4. I know I'm taking some shortcuts, guys, showing the work. That's just because I don't want to waste your guys' time, okay? So I'll get 2 squared, which is 4 times, so we're going to multiply this by negative 1/4. And this is where we might actually get a whole number here, because negative 1/4 times 4 is negative 1 plus 4. And that's going to give us 3. So now we're finally at that actual whole point. But see how much fatter this one is from having a multiplier 1/4? It's way fatter. Okay. And then if we went to 3, it will probably increase a little bit more. So I can just keep going. Okay, so there's my parabola. I could have checked 4. I would have gotten, I don't know exactly what I would have gotten, but it would have been somewhere between 2 and 3, I'm guessing. Okay, maybe between 1 and 2. And that's it, guys. So the first step is always to plot the vertex, and then you're just going to need to actually plug in the x values to the left and to the right to make sure you know what your y values are on each side of your vertex. Again, eventually you will notice some patterns here, but I want you guys to try to discover those patterns on your own. Okay. Oh, and I want to leave you guys with an awesome math joke. Why is the obtuse triangle always upset? Why is the obtuse triangle always upset? Because it is never right. Have a good day, guys.